My name is Laurie French. I work in client engineering along with Dale, and my role is software engineering as well as designing for rapid prototyping for a bunch of our enterprise clients.
And my name is Dale. I'm a developer also for IBM, and we work in a bit of IBM called client engineering. We'll really quickly explain what we mean by that. Actually, do you want to go with that bit?
Yeah, of course. So I briefly mentioned we do lots of rapid prototyping. So our kind of methodology is building demos in short periods, usually from a couple of weeks up to a couple of months, to kind of realize the industry value sooner for our largest clients. And we have lots of different pillars of our methodology. So you can see a lot of it's around like building a new culture of greater collaboration with our clients. We do lots of co-execution and co-creation. So the idea is that we're not kind of the code monkeys that just build for them, but they're integral along the process and they're a part of it. All of which is part of this process of like transforming the way they work, building greater innovation in their industry.
So Laurie's mentioned our methodology, and it's this sort of combination of a load of best of practice from across industry, design thinking, agile, cloud native development, tons of things. We've put it all online. So, everything about the way we work is sort of public, the process that we follow. And that's kind of what we're going to be talking about today. We've picked one of the aspects, one of the ways that we work with our customers, one of the ways that we deliver software projects, and we're going to be sort of telling you a bit about that. So what we're talking about is DevOps, or a particular way that we do DevOps. I'm guessing most of you, sort of in the room, nod if you know roughly what DevOps is. You've heard of it before. I'm seeing a sea of bobbing heads. That's good. There's not one definition, but we've picked one that we like here. Talks about this idea of bringing development and operations together, of automating everything that you can, encouraging collaboration, and we'll talk a bit more about that in a moment. But it's how we approach DevOps. That's what we're going to be talking about today.
Great. So one of the things we mentioned was that we use design thinking methodology within our team. And so an activity we run all the time with clients is empathy mapping. And that's basically, we'll take a persona. This is Linda. She works in an ops team in incident management. And we'll try and ideate on what are the things that she says, she thinks, she feels, she does, which kind of encompass this problem of which we're trying to resolve. And so when we take a look at some of the things that Linda is doing, right now, lots of manual work, right? I mentioned she works in the incident management team. She'll be documenting all of the tasks that she's doing to resolve errors that occur. There's lots of manual work there around like copying, pasting the commands that she's using and attaching the screenshots of what's then returned. And as well as like the ability to then create channels to discuss it with people in her team to resolve these issues, all of which that burden falls on her to do that process end to end. And so some of the things she says and thinking around there is, I believe there are better ways to do this way of working. And I want to make it clear this is incident management. ChatOps is relevant to many other areas, but certainly the level of work that she's doing and the pain points of how she's carrying out these tasks, how she's querying on issues, how she's resolving them, she believes there's a better way. And so unsurprisingly, right now her feelings are frustration, stress, agitation, etc.
So that's setting the scene, right? That's sort of DevOps and what it's like to be someone working in DevOps, like Laurie says, in particular, responding to incidents, that critical system down, 2 a.m., you've got to figure out what's going on and stand it back up again. So ChatOps is a way of approaching that. And we're going to show you all of this in a lot more detail, but just to give you a flavor of what we're talking about, automating what you have to do, bringing the information together into a single place, getting that information to your ops team in real time as they need it. And more importantly than anything else, enabling and supporting and fostering that increased sort of culture of collaboration.
So what's the benefit of this? We have these 5 points here. So one of the parts is team communication. The idea is here that you're making a really transparent foundation for people to know what you're doing, why you're doing it, what the result was, so that as a team you can more effectively communicate on the task that you're doing. And then as an association, hopefully you have increased productivity. People are aware of what they're doing. They can easily find support. They're facilitating the tasks that they're doing to lead like greater efficiency within the workflows they're doing. I mentioned the transparency point. You're aware of what people are doing. You have that level of visibility, but also inherent to that is the knowledge sharing, right? You get to learn from other people because you see what they're doing. You get to have that visibility of why they've done those things, to question them on it, to learn from their experience. And then that can be used to facilitate onboarding. So when someone doesn't know how to do incident management, they're new to the team, they have this culture there to support them with upskilling so they can be useful.
So ChatOps is about bringing together ops into a communication platform. It's about using a communication tool, as the venue, as the place where you discuss and plan and debate and action your DevOps work. Now, for me and for Laurie, we use Slack a lot. We adopted Slack years ago. So for me, communication platform is synonymous with Slack. I'm going to try not to keep saying Slack, but I'm blatantly going to because it's just become a verb and a noun for me. But if you use Teams or Rocket Chat or that other one that I can't remember, I wrote these slides a while ago and I forget what logo I got, but it's another thing a bit like Slack. Like when I say Slack, think something where there's channels and people can type in real time and you can add attachments and rich text and all that kind of stuff. So there are lots of different ways of approaching ChatOps. What we're going to do is we've set up like a not totally trivial application, and which is a bunch of Java apps that are sending messages to Kafka with Zookeeper. I love Zookeeper's logo. Sort of coordinating it all, and we've got an ops team who needs to look after this and run this. And what we're going to do is show you 10 different ways of applying ChatOps to it. So we've got a bunch of different demos, and we're going to sort of show you how these different approaches, different ways of doing ChatOps can help them. And by the time we've finished, for the next slide, it will look like this, because we're going to try showing you all different tools that we can chuck into the mix. Everything that we're going to show you is on GitHub. We've got the short link at the top, ibm.biz/chatopsdemo. We're going to keep this on loads of slides, so don't worry about writing it down too quickly. But all the commands that we run, there's going to be a shell script so you can see exactly what we're doing if you do want to sort of dig into it a bit later. One last thing to say about the demos, they go a bit quick, and it's all based around Kafka running on Kubernetes. If you've never touched Kafka and Kubernetes before, don't be put off, don't be scared. As long as you get the gist of what we're talking about, of how ChatOps can help an ops team, it doesn't matter if my rambling about Kafka replicas and brokers goes a little bit over your head. Do you want to take that one?
Sure. So before we talk about any automation, which obviously we're going to be doing demos for, the first starting point for ChatOps is just greater transparency. And so you can start by leveraging your real-time communication channels, right? We're talking about Slack, just to document what's happening, why you're doing it. All, as we said, the fundamental pillar of this is that transparency. So before you write any scripts, you do any of this work, the first step is just consolidating the information of what's happening in a channel where everyone can see what's going on, and that will go a large part of the way towards that cultural transformation to be able to have the increased productivity, efficiency, etc., that we mentioned earlier. But we can do even more. So obviously it'd be kind of boring if we finished there and just said, just put it all on Slack, be communicative with each other, be open. But there are further levels to this. And so this goes back to Linda and the pain points that she was having, right? Around how can we consolidate the way for her to interact with these different platforms? And how can we make sure that the collaboration is kind of instigated and inherent to that flow, with the bot kind of triggering those questions, building that conversation, and as well facilitating things like knowledge share so that retrospectively it can be studied and learnt from.
So let's get to our first demo. So for this one, we're looking at how an ops team uses PagerDuty. We're using PagerDuty as an example of the kind of tool that does when there's a critical incident, it knows who's on call, it bleeps them, it tracks who's working on which issue, tracks that issue through to resolution. So how can ChatOps help with that? So, like I say, we're going to be using Slack for these demos. So to start off with, I'm in our collaboration channel. This is me, but I can see someone else is starting to ask. So Nigel is asking the bot, am I on call? Saves him having to go actually look at PagerDuty. The bot can check the schedule. Nope, you're not. Dale is. Oh, when am I on call? It can give him his schedule, when his next on-call slots for the next couple of weeks. And that sort of nudges me, because maybe I'd forgotten that I was on call, because I'm not very organized. So I can ask the bot, am I really on call? Yep, you are. Maybe that's a problem. Maybe actually I'm going to be offline for a couple of hours. So I can ping Nigel and say, I need to go offline for a couple of hours. Can you cover for me? Fortunately, Nigel's very helpful. So he can reply and say, yup. But more than just replying to me to say yes, he can ask the bot to update the schedule. So he can ping the bot and say, put me on call for the next 2 hours for anything that's going on with Kafka. Now, All of that we could have done by going to the PagerDuty website, because all it's done, all the bot's done on our behalf, is updated the schedule, added in an override. All of that could have been done there. But the point is, we could do it all without leaving Slack, which is where we are communicating, where we're discussing stuff. The idea is, as Laurie was saying, it's very transparent. Everyone knows what's going on. You can do all of the discussion in the same place. Now, unfortunately for Nigel, as soon as he's got the page, something's going to go wrong. So what I'm doing here is creating an issue. There's some major problem with the Kafka cluster. Messages aren't getting through. Because he's now on call, he's going to get beeped. It's on him to fix this. Now, I don't know if you've ever done PagerDuty. When I first signed up to it, I just put all my contact details in. So my phone, and I had the app, and I had my home phone number. The first time I got paged at 2 a.m. It rang my home phone, my mobile, it sent me a text, the app started beeping, all at the same time. Don't do that, pick one. So Nigel will have picked one way and he'll be getting beeped now. But even if he hasn't picked one, Slack is another good place to do that. So what will happen, the bot will ping him to say, well, firstly, it will put a message in the general channel so that everyone knows. All the ops team have that visibility, of that situational awareness that something's going on. So they can see what's happening, the summary, and who's been assigned. So Nigel's going to pick this up. If he hasn't already acknowledged the page, he can do that in Slack as well. So by doing acknowledge, that means that he sort of tells the system that, yes, he's aware there's a problem. It saves anyone else being escalated to and paged. But maybe he looks at this and thinks, well, this is complicated. This is going to need a bit of discussion. And not everyone in the channel is going to want to be sort of spammed by this. So he might want to create a new custom channel just for this one incident. So he's going to sort of put a message in there saying, this looks bad. I'm going to start a separate channel to investigate it. It's really good practice to have a naming convention so everyone knows where to go and find the channel. And the bot can help with that. So if you just click on Create Channel, it knows the incident number is 7, so it's going to create a channel, Kafka Cluster Incident 7. So, and it puts a link to that in the general chat. So anyone who wants to follow along and see what's happening, click on the link, they can go and see what's happening, or maybe pitch in if they have some insight or some knowledge to share. But for Nigel, he can, and coming back to what Laura was saying before, even with that automation, go and grab logs, stick the snippets in the logs in Slack. You've got that history. This is what I can see. This is what I'm going to try. I'm going to try running this command now. So that everyone else can observe, everyone else can chip in with their suggestions, their comments, give you their opinions. And after the incident is finished, you've got that record of everything that happened, when it happened, who did something, what did they do. So like Nigel's going to try bouncing one of the brokers. That made it, that worked, that's fantastic. Can tell the bot, add a note to the PagerDuty ticket so that other people who aren't in the ops Slack workspace, maybe a way of getting updates out of there. The idea is that do everything in that one place, that Slack becomes the home for your ops team to communicate with systems and with other people in your organization. I should mention actually that there's a whole load of different types of bots we're using. We're using one called Hubot here for this demo. It's one that was started by GitHub, and it's how they do a lot of their DevOps work. It's a really cool extensible platform. So again, all of this could have been done by going to the PagerDuty website and filling in notes and doing all of this. But the point is the bot has updated the history in PagerDuty on Nigel's behalf for him. And once, now that he's happy it's fixed, he can tell the bot to resolve the issue, sort of say, yep, this is done, we're finished with this now. So the bot will make sure it's closed off and reported and so on. And it'll put an update in the main channel as well, so everyone else who was following can see. Should we move on to the next?
Okay, sorry, yeah, so clearly, that helps simplify the team coordination because instead of them having to manually themselves go to PagerDuty, change the scheduling, be able to get the notifications of when there are alerts, they get through that in the medium of Slack, which they'll be using anyway. And as Dale said, you could go and do that manually, but we're consolidating the information again so everyone can see it. So people are aware, why did someone change who was on call, what happened, that's all in a medium that everyone has access to without needing to navigate to this other service. But we can go further. So one of the things we can do is actually do timely notifications to get updates on our app status based on when alerts occur or any other issues.
So for this demo, like I said, we were running applications that are talking to Kafka. We've instrumented the Kafka cluster, and we'll show you how we can use that. So what we're doing here is running an app called a canary. It's just going to put a message and then get a message, and keep doing that in a loop. Because as long as it's able to do that, we know that the cluster is basically up and running. And we can see here there's a topic called Strimzy Canary that we're using as that sort of, is the cluster still alive? So what we're going to do as our first sort of notifications demo, we're just going to kill the canary, which is a lovely emotive way of saying it. So to start with, everything's all right with the world, put a message in the general notifications channel, ops team are happy. But we're going to kill the canary, and what we want to see is how the ops team could be notified that there might be a problem here. Now, under the covers, this Kafka cluster has been instrumented. We've used Grafana and Prometheus, and we've set up a whole bunch of rules to alert on, things that could indicate a problem. So if you care about Kafka, you'll recognize some of these kinds of things. But the one we're talking about here is that there's been no message on the canary topic for a minute. That's what the 1M is there. So if no message has hit that topic, if the number for the number of messages on the topic hasn't gone up for a minute, that indicates there's probably something wrong. So if I was watching Prometheus, I would see this going to a pending state. If I waited until the minute was passed, it would go red, it would go firing. But the point is, I'm probably not looking at Prometheus when something goes wrong. So where would we want this information? Well, you can probably guess we'd want it in Slack. So we've set this up so that Prometheus will post messages into Slack when any of those alerts fire. And like I say, remember, all of this stuff is in GitHub. So if you want to see how we configured Prometheus to post into Slack, all of the config we used is in Git. But remember what we said, so your ops team can respond. They can put, I can say, I'm going to investigate this. I can say what I'm looking at. Now for this, I'm just, I can maybe look at what pods are up and running. I can see that the Canary app isn't running, so I'm just going to restart it. So I just put a message in Slack to say that, oh, it looks like the Canary's down. I'm going to restart it now. I can say what commands I ran. What did I do? What am I thinking? What am I trying? It's really good for new members of the team, who can lurk in the channel and see how I approach it, learn what commands. They might pick up some tricks of how I investigate it, what I did to restart it. And then after I fix it, Prometheus will post a message when the alert is cleared. So everyone in the team knows things look okay.
Sorry. No, okay, so then that's been resolved, but we can get alerts for other types of issues. So one of the things we can do is look at the disk space. So clearly, as we said, you want to be told if your Kafka cluster is down, but also if it's starting to utilize too much space on the disk for what you then have available. So what we're going to do is we're just going to start spamming it with tons of messages until we start filling it up. And what we're going to see again is the real-time notifications within Slack to say, you need to investigate this. This is becoming really populated. Clearly do something about this, whether that's you increase the capacity, you delete things on it. But this is obviously the process of just spamming it with 19 gigabytes of data. And I can fast forward to kind of show you what's happening. But we can start to see, so right now it's at 300 meg, but if we just let this program run a little longer, we can see that it's starting increasing in size. So we're now at 2 gigs, jumped to 10.42 gigs. Obviously, we were just speeding the time up. But we'll see, eventually we'll start getting notifications when a threshold is set that we need to do something about this because there's a concern here. So our warning, you only have 14.7% free space on this cluster, right? You need to do something about it. And again, this can be the impetus for the team to do whatever remediation that they need to, but that stems from getting this central communication channel alert for them to go and investigate. And so what we can see here is Dale's again going to document within the channel so everyone knows what's going on. Okay, clearly this is not good. I need to do something. I'll check if we can get rid of anything on that disk or if we can increase its size. And again, as Dale was saying, all of these steps that are being taken are visible to the entire team. So they're aware there's an issue. They understand the remediation of what needs to happen, which can be retrospectively studied should a similar issue occur. And then we should also get the real-time update when there is greater capacity once that resolution has occurred. There we go. We've got the nice message there to confirm everything is all, we've got the nice colouring, the red for there's a concern, green it's all fine, and that's no longer an issue, again, all of which has been documented.
So I said don't worry about Kafka, but I'm a Kafka guy, so if I can inflict Kafka on a room full of developers, I absolutely will. So that was my sneaky trick. I'll keep this brief. Kafka is highly available, and the way it does that, you create a topic, it will live on a broker, and in the background, it will put a replica on another broker. So if a broker dies, you've got a replica that can become the leader and can take over. So the idea is that broker 1 is going to be making a copy of all the messages that are hitting broker 0 so that it has an up-to-date copy so it can take over. Normally you'd have replicas on multiple brokers, but we won't get too complicated for today. The reason I mention this is this idea of having an up-to-date copy is intrinsic, because if your copy isn't up-to-date, your cluster isn't really highly available. So Kafka people, we care about replication. We care about is replication keeping up. So that's kind of enough of a scene setting to explain the next demo. So what we showed before is getting notifications when things are going on in like the Kubernetes side, but what does that mean in a Kafka world? So maybe we've got a message that's going to a Kafka cluster, to a Kafka topic, it's hitting one broker, and another broker is maintaining an up-to-date copy. So you can see what I'm doing here is it's going to, in a sec, the script is sort of going to check where this topic lives. So the leader, the main home for this topic is broker 1, but another broker is going to be maintaining a copy. And I'm sending messages to that broker. So every time I send a message, another broker is grabbing a copy of it and maintaining an up-to-date copy. Now, what I'm going to do to represent a bit of a problem is so the copy is on broker 0. That's what the replicas means. Broker 1 has the main topic. Broker 0 has got the replica. So I'm going to screw around with the networking so that broker 0 can't talk to broker 1 anymore. So I've got this script, prevent replication. It just puts like a network policy in the way that screws up. But what that means is messages are still hitting broker 1, but broker 0's copy is getting further and further behind. My cluster isn't highly available anymore. So as an ops person, I need to know that. So that's kind of setting the scene, and you can guess what's going to happen next. What we want is alerts to hit Slack. So again, this idea of, and you'll be able to see the config in Git for how we've done this, but which topic has become what we call under-replicated, is no longer up to date. Our cluster is no longer highly available. I mean, this is a very Kafka-specific thing, but think about what applications do you run, build, monitor, maintain? What are the indicators that would be critical for you that you would want to know about if something happened? For a Kafka person, something like topics being under-replicated is sort of the top of the list for me. Like I say, how we configured Prometheus, all of the rules that we've used, very Kafka specific, but if you want to see the approach we took, they're all in Git for you. And you can see we added loads of different rules because this is the basis of how we actually do run and monitor our production Kafka cluster. So you can nick some of our ideas there.
So to go back to the value that would add to Linda, clearly she's getting the real-time alerts within the medium that she's discussing with her team anyway, from Prometheus of what's going on, right? So that she knows, I need to do something about the disk, or I need to look into the fact of why it's not replicating and do some investigation, so that she can make sure that her app is always available and always performing. However, you also most likely want to query on the current state of the application, right? And so let's simulate that with our bot also. So we can use Slack again here and say, OK, can you please get me the status of my Kafka brokers? And we're getting the metadata there around like, OK, well, what pods are there? Are they running? What's the restart count? When did it most recently restart? And we can also link out to the third parties that we're obviously interfacing with. So I actually want to go into the terminal within the Red Hat OpenShift platform, all of which we can trigger from the links in Slack. We can ask as well for other components. For example, I don't only want to know about my Kafka brokers, I actually want to investigate Zookeeper. Again, all of that get that metadata also. And then we want to show that it's kind of performing right. So we're actually going to simulate a crash and see if we're going to get that represented in the messages that we're then being queried on when we're asking about the status of our brokers. So you can see that now there's been a change. So the pod's gone from 1 to now 0. And you can see the restart count is incremented also from 1 to 2, with the update timed as well of when that then occurred, showing essentially that it is live. It is actually pulling the most recent information because it's obviously figured out that it did indeed crash.
One thing to point out is when I recorded this, I tried, every time I asked for the status, I tried to come up with a different way of phrasing it to show you're not typing in commands. Like, you can configure these bots so that they understand like a fuzzy general description. You don't have to be word perfect as long as you get the gist of it across.
So we can also obviously get warnings. So beyond just being able to tell what the current state is, maybe we want to drill down into, okay, there's a warning, what has happened, can you give me the information about that? And again, link out to the application itself to be able to investigate that within the relevant platform. And we can get logs as well. So we can get that sent over to Slack so we can all investigate it together in the central medium, which again is obviously being pulled from the relevant parties. So this point about transparency, right? We could say, okay, I've studied the logs. I found the exact error that I think is being caused. I want to try something out. Let me confirm by querying on the state of Kafka that it's actually improved. And we can see, for example, here that the restart account has now gone to 5. It's continually restarting. So we're getting that evidence of how it is based on this querying. But also, as Dale was saying, a newbie that doesn't know what's going on, take newbie Nigel, he's seeing all of this. He's understanding, okay, Dale looked at the logs and found this part relevant. And that's what he then did to run these exact commands that brought about these exact results, so that should a similar situation arise, he has that documentation of what he can do.
Should we go to the next?
Cool.
So getting information from lots of different sources. So what we showed is like the sort of Kubernetes style. You can ask the bot to find out what pods are running. But you can instrument your apps to be able to respond to messages as well. So what we've got here is I can ask it about, so we've set up the Kafka cluster so it can respond. So here I can ask the bot, what topics do I have? And here's my list of topics. I mentioned that are they in sync is like the thing I care about the most. So the bot will tell me, yep, there's nothing out of sync, little sort of party confetti emoji to make me happy. If I ask for the details, I can find out which brokers each topic lives on, where the replicas live. What's the kind of information you need most frequently? What are the commands you're running all the time? Get the bot to run them for you. So if, again, like before, if we sort of screw around with replication a bit, so monkey around with the network, again, so that brokers can't talk to each other, so that we're preventing replication, so we can see how that shows up when we ask the bot what's going on with the topics. So remember, because we've got this instrumented, notifications will be going in. For this demo to stop it making noise, they're going into a different channel. But you can either have it so the bot can tell you when something goes wrong, or you can make it like we'll show you now, where you can ask it. So you can see the notifications channel is lighting up. But here I can say get all topics, and now it's telling me one of the brokers looks like it's gotten out of sync. 8 topic partitions are no longer up to date, are affected. So I can ask for the details. I can say, well, show me the out of sync topics, and it would give me the list. So here are the 8 affected topics. I can ask it to give me the details, so I can see, well, where are these problem topics all living? And I can see that what they've all got in common is it's broker 0 that isn't keeping up. So that tells me roughly where the problem is. And again, like before, like now I can go and investigate. I could ask for logs, like Laurie was showing you a second ago. But for this, I'm just going to put the network back so it's working again. So I've got a script that restores the network settings so that the brokers can start talking to each other. And now the cluster should start getting back in sync. Broker 0 should start to catch up on what it's missed while it was out of communication. And I can ask for, tell me what out of sync topics there are, and the bot says, there aren't any. Everything is good.
Okay, so again, the benefit here to Linda is that she's not having to navigate to these apps to be able to get that information. She can query it from the central repository that she's already using on Slack to get the up-to-date notifications. However, clearly there's value in not only knowing what currently is going on with the system, but historically how has it behaved. And so now we're going to show a demo that's linking with Grafana to be able to get metrics around like network usage, CPU optimization, things like that.
I'm sure a lot of you will have seen Grafana before. I'm sure a lot of you will have set up elaborate dashboards that you never remember to go and look at, or they're on some screen in the corner of your office that you haven't been in for the last 2 years. You can take that ability to generate visualizations from the data you're collecting, from the metrics and the monitoring that you have, and bring it into Slack where it can be useful when you're investigating problems. So again, we're running an application here just to get some traffic being pushed through the cluster, just so that my graphs aren't totally boring. And I'll start a couple of other apps as well, put the canary back into it and things like that. So now I can ask the bot, so I can see the topics, there's a disk filler one again, and demo and so on. So we can say, well, show me the network usage. And by default, it shows me for the last, I can't remember, a couple of hours, a few hours, I think it is. So it's a Grafana visualization, but it's worked out what cluster I'm talking about. It's queried Grafana, generated the visualization, brought it back and stuck it as an attachment in Slack. And you can imagine what other things I can do. So I can say, well, show me the network for the last 5 hours, just to pluck a number out of the air. It's not a very busy Kafka cluster because it was one that we set up just for this demo. So imagine this had a more interesting line on it. Show me the disk usage. So from that earlier demo where we were spamming it with 19 gigs of messages, you can see the available disk plummet. So that's the kind of stuff you can get into Slack. And like before, where you had the pods that were all links to the OpenShift where you can go and interact with it, each of these is a link to the full Grafana dashboard. So if you want to go and see these visualizations in Grafana, you can. And that's really useful. Like if you're an ops person that has to look after more than one app, more than one thing, like when you get that 3 a.m. page, you're not going to remember. You're not going to have all those bookmarks and links at your fingertips. The fact you can ask the bot for a bit of information, then it gives you the link so you know exactly where to jump to. That is super helpful when you're tired and stressed and you need a quick answer. So any of these visualizations, you can ask the bot for and it would drag it into Slack for you.
So the value here is obviously, we're not having to navigate to the third party. We can trigger it from the Slack medium. We don't have to save those bookmarks, as Dirk was saying. But besides only querying on the dataset, well, not dataset, sorry, but querying on the state, we can also actually request changes and make them. So in this demo here, we're going to be updating the settings. Let me put this forward. So we're sending big messages to Kafka, and these are going to be around 2 meg, which are is too large for what is the industry standard of what you should be applying. And so we're going to simulate that we're going to change the configuration settings for this. So you can see here when we're showing it the size of messages that are going into the program. And when we ask the bot for the config, it can return that back and say, okay, the message maximum byte size you set was 2 megs. And then what we can do is we can say, okay, I actually think that's too large. We need to change that. Can I update those settings, triggering it from Slack? So we're querying on the bot, and we're saying, okay, can you actually change the config message maximum byte size to a meg and update that? So what's going to happen is clearly we're actually receiving messages that are far larger than that. And so the fact that we've updated this configuration should mean that those messages no longer are labeled to be received. And so we should start getting warning messages saying that, we haven't received any messages in the past minute, it's not being able to be consumed, which has clearly happened as a result of us updating the config through the Slack medium. And obviously this shows it, so we're getting lots of error messages here about it's just too large, it can't be processed. And we're getting the alert as well, saying, okay, we haven't actually had anything for a minute because they're too large with the large message error. So we can obviously go back and revert changes again, applying the same logic of being able to do it through Slack to update the configuration. And obviously, we could integrate also with Grafana to be able to understand why it's being throttled, what has occurred when we're looking at the network usage. So if we now go in and we say, okay, well, I want to change the size that I'm allowing for the maximum message, I want to increase it again, we should see those errors disappear because clearly they're now being accepted. Again, the whole point is this is all being triggered through Slack. Cool, and they're now all being received, so that's all fine. And we'll get a message from the broker letting us know that it's all good now. But also, we spoke about how ChatOps can benefit with onboarding. So we're going to show now how you can assign permissions by querying on the bot in order to bring people into the team and give them the relevant permissions that they require.
The more you can get to a point where the sort of common ops tasks that your engineers are having to do all the time, the more the bot can do it, the more the bot can know who's allowed to do that. So you can see here, Nigel's asked for the config, and the bot has said, no, you're not on the list of people who's allowed. But maybe that's an accident, maybe that's an oversight. So Nigel can ask me, no, I need to check this. Can you tell the bot that's okay? If you've ever had an onboarding process, like the fact that I don't have to go and find the right tool, I can just ask the bot to fix it. The bot knows I can be trusted because it will let me do this command. So it knows that I'm allowed to tell the bot who else can be trusted. Particularly when there's an emergency, there's a critical situation you're trying to investigate, you don't want to have to faff around with access controls. Having the bot help you do that, help get new members onboarded, is fantastic. So now the bot knows this person can be trusted, Nigel can ask and gets the information he wants. But I told the bot that Nigel was okay to check the status, but I didn't tell the bot he can change things. So when he tries, it will still tell him no. It will say, you can't modify that config. And he did it in an open channel where everyone can see, so I get to tell him off. But actually, transparency is good. Doing stuff where everyone knows what everyone else is up to is really beneficial in a busy ops team.
So, as Dale's alluding to there, the transparency means that you can prevent people from potentially doing things that are inappropriate because you have the visibility of the commands that they're running, why they're running it, and obviously the ability to change their permissions if they're going to be doing something which is inappropriate, and also learn from them, right? So you get that documentation of, well, you can't make that change for this reason, and that's been captured in a Slack message, so should anything happen in future, they can refer back and study it.
So we've done, the commands we've shown you so far have all been quite granular, essentially getters and setters. And that is useful. That's your low-hanging fruit. Find the most common commands and get the bot to be able to do them. But where it's really helpful is those complex tasks, those multi-step tasks, those really fiddly, manual, error-prone tasks where you've got to do multiple commands in a row. Because again, I keep coming back to my 2 a.m., 3 a.m. wake-up call. Those are the times you're going to screw up those complex, manual, fiddly, error-prone tasks. So if you have a runbook that has been battle-hardened and tested that the bot can run for you, that's a much safer way of doing things. Given the time, I won't inflict more Kafka on you. I'll just say this. If you want to move a topic from one broker to another, it's horrid. You basically run a command that generates a file, a JSON file. You then edit that file to reshape it a bit, and then run another command that you give that edited file, and then it does something, and then you run a third command giving that. It's not something you should be doing at 2 a.m. So this is the kind of thing that, if you have an automated process, an automated runbook, the bot could run for you. Because I've done monkeying around with production clusters at stupid o'clock in the morning. It's not a sensible idea. So here, we'll have that same kind of idea of there's a problem with one of the brokers, and we're not going to be able to recover that broker quickly enough, so we need to move all of the things that broker was doing onto other brokers in the cluster. We're going to need to move some topics around, and like I say, a really complex task. So the kind of thing a bot is ideally placed to help with. So we're going to create a topic to start with. We called it tiny messages, and we're going to sort of slowly start putting messages to it. This topic lives on broker 0, and there's a copy somewhere else in the cluster. So it's going to send a message saying hi. Like before, we're going to screw. So yeah, this tiny messages topic lives on broker 0. There's a copy on broker 3, and actually broker 3 has got copies of some other things as well, and actually is the leader for one of them. So broker 3 is a busy, active member of this cluster, except we're about to do horrid things to it. Actually, if we pause on that one, there's one of the things. I mentioned risky, I mentioned error prone. Don't just have a command that lets someone restart a broker, because if the cluster isn't up to date, if we don't have up-to-date replicas, that's risky, you'll lose data. So having the bot check if something is sensible, being able to ask the bot is it okay? Is it safe for me to restart a broker? And it can say, yeah, everything's fully replicated. You can bounce any of these. Won't impact anyone. Knowing what's safe to do, that's the kind of thing a bot can help your ops team with. And if you get it to stop your team doing silly things, even better. So like I say, like before, we'll screw around with the networking. Broker 3 no longer is going to be able to talk to the others. Its replicas are going to start getting out of date. So you saw before, I can ask the bot, well, which topics are in sync? What topics have a problem? I can ask for the status of individual brokers. I can get all that granular individual bits of information. And so it can tell me that one of the brokers has a problem, 4 of the topics are affected. But like I say, it's not just about individual tasks. Where this gets really helpful is where you want to do these multi-step tasks. So I can ask the bot to start moving some of these topics. So you can actually just quickly there, is it safe to restart? It's not. Because there are topics that aren't replicated, some of the copies have started falling apart, it isn't safe for me to start restarting things. I need to move stuff around before I can do that. So that's what the bot will help me with next. So I can ask it, and again, phrasing it in lots of different English ways, but I can say, move that topic to that broker and put a copy on broker 1. In reality, that takes a little while, so that's why it's saying it's submitted a request, because it's going to take time to copy all those messages over. But now, that is no longer on my list of topics are out of sync. Before, there were 4 topics that were affected. Now, because that topic lives on a broker that's still okay, that's one less problem. So I can just keep going through my remaining topics and saying, well, move this topic to that broker, move that topic to that broker. In reality, I'd look at like network traffic, disk usage. I'd make an informed decision about what the best broker to host it would be. But for this demo, I just picked numbers at random. But once I've moved everything off of broker 3 is still knackered, but it's not responsible for anything. So the cluster will hopefully be healthy, and then I'm going to be free to start restarting things. So now I can say, show me the out of sync topic, or show me all the topics. I'm back to green, I'm back to party emoji. I don't have any out of sync topics. So now I can say, is it safe for me to do a restart? Yes, it is. Even though broker 3 is currently having some problem, it's safe for me to start doing restarts. And that's the kind of thing I can ask the bot to do as well. I can ask the bot to restart broker 3. So you can get to a point where if your most common ops tasks are all recognized by the bot, you can do everything from inside Slack. And the restart brings it back up and running. If I want, I can start moving some of my topics back to broker 3 now.
Okay, so there's lots of scope here to actually improve the AI under the covers of how we're getting our bot to understand and interact with the team. So I think people sometimes think about AI, like obviously the worst example would be Clippy, right? Like, we see you're talking about Kafka, do you want education on it? Most likely not. I assume they're educated and that's why they're working there. But there is actual real use cases, 3 in particular, of how we could make this more sophisticated to add greater value. And so the first one is around, right now, we're kind of instigating those conversations with the bot, right? But how would it be useful, or surely it would be useful, if it could actually recognize when there's moments that it could add value and say, okay, for example, I've picked up a signature. This conversation has happened before in a similar context, asking similar issues, and I know the resolution that was taken to overcome it. And so I can bring you up the retrospective logs, the actions that were taken. I can suggest like educated, valuable suggestions of what to do as a result to better improve the efficiency and the productivity of the team with that greater understanding. The second piece as well there was around being able to connect with other teams. So if you're seeing like one group is having very similar conversations to another, even if they are in siloed environments, surely insinuates there's an opportunity for collaboration there, right? The issue isn't localized to a specific team. They should be made aware of that. That would be helpful. And so how can a bot recognize the patterns of conversations that are happening in different environments to collaborate and bring multiple teams together? And then the other part is obviously we've shown the more complicated journeys that it can do, where it's not just give me the state of something, it's actually going and executing those tasks. Clearly the scope to build in greater sophistication of the level of tasks that it can do, the sanity checking that it can do before you then do your work, also has greater benefit, right, and greater scope for how that could be implemented. So
let's recap. What is ChatOps? ChatOps is about automation. Automating, you saw us get the config for the Kafka cluster. It not only said this override value is this, it described what that config value meant. It had a link to detailed documentation. It had runbooks that could be automated and invoked from a message in Slack. Automate your ops work, bring it into a chat world. Bring all of that information, your investigation, if you had your network guys and your disk experts and your Kafka experts and your application team in one channel discussing stuff together, consolidating all of that, the alerts from Grafana and Prometheus, all of that in one place. Doing that in real time, when the incident is happening, when they need to know. But more importantly than anything else, get your team talking to each other, get them working together, get them used to doing this in the open as a team.
So hopefully as well, the value of this makes more sense. So when we're talking about team communication, that was inherent to this methodology, making that space where everyone's talking to each other, you know what's happening, it's open, it's honest. And the productivity as a result, you can outsource some of the tasks that you're doing. You don't have to navigate between all these different panes. Lots of the manual laborious labor that is involved in this, you have the scope to automate. The transparency, kind of inherent to the communication there, you're seeing what's happening, you can learn from others, a big part as well of the knowledge share and the onboarding. So to wrap this up, how does that help Linda? Obviously, she was the persona that we started with when we were doing the empathy mapping. And these points here around the pain points that she had previously with the manual tasks that she was doing that can now be automated, or the fact that that communication is not encouraged or facilitated, that's then changed. And all of that is a result of adopting this methodology where the bot is then creating that space for her to discuss it with people, automating some of the work on her behalf, as well as bringing that culture of transparency and honesty within the team that she was already working in.
We've been using ChatOps for a long time now, and incrementally you add to it. Like every time there's a command that you're running all the time, you add that to the list of things the bot can do. And the problem with us showing you quite a sophisticated thing is that might be putting you off. It all looks too daunting. If you have one takeaway from this, give it a go just where you use Slack or some communication tool as a place to discuss things. Pick a project, set up a channel for it, tell your team, encourage them that from now on, we're going to try out for the next few weeks. Anytime we're discussing an issue, we'll share what we're seeing in the logs, we'll share what we're doing, we'll copy paste in the commands, copy paste in screenshots, do it all manually, but see what benefit you get from it. And if it's useful, then you can start adding in the cool whizzy demo things that we've been doing. But just start seeing what cultural impact it will have in your team. And if you do want to steal any of the ideas we've had around how we set up the integration of Grafana with Prometheus, Kubernetes logs, restarting pods, even if you're not doing Kafka, there's a whole bunch of things in there that you might want to nick. Feel free to go and steal from the demo. And with that, we've left ourselves 3 minutes for questions.
I'm just wondering, obviously you've done this for a while, did you notice anything in terms of actual data, like your response time to incidents?
I don't know. That's a really good question. So so a lot of the where we nick the ideas for this is from the team, colleagues of ours who run IBM's Kafka cluster. And what we've got here is like a really simplified, noddy version where we've pinched some of their best ideas. So they've been running this at scale for years. And I never thought to ask them that. They showed us.
This would make my life easier selling this.
Yeah. I really wish I'd thought to ask Charlie that, but we didn't think to ask. I know that it's just become their default norm now, but in terms of what it was like before they did that, I don't know.
I mean, you're IBM, you'll have the data.
I'm sure, yeah. I mean, I did mention GitHub, but we're all standing on the shoulders of giants, right? Like Hubot, the framework that we use to build the bot is from GitHub, and they've been adopting this for many, many years. So I'm sure if we look on the Hubot site, they'll have some metrics there on the impact they've seen. Brilliant. Well, thank you so much for your time. Thank you for listening. We're going to be around for a bit, so please come talk to us afterwards.